Hi, 7th grade. I'm in my living room this time, and I would like you to get out your books if you can and open up to page 11. We are going to start going over section 2, which is talking about the properties of waves. So I have some notes that you can copy down if you'd like to. I will try to include these as part of the lesson that I will show you. And we can kind of go from there. So the properties of waves, there's 4 main properties that all waves share. And it's that they have amplitude, they have wavelength, they have frequency, and they have speed. So I'm going to turn the page to page 12. I have my book in front of me. And we're going to start talking about amplitude. But before we do, a way that I remember those 4 is I made a silly saying out of the A, the W, the F, and the S. And it's always wear fuzzy socks. So A, amplitude, always. W, wavelength, wear. F, frequency, fuzzy. And S, speed, socks. Always wear fuzzy socks. So if you can remember that phrase, you might be able to remember the 4 things that waves share. So the first thing that we have is amplitude. And this is the maximum distance that the particles of a medium carrying the wave move away from their rest position. And so I have some notes I'd like to show you. Hopefully this works out. Let me see if I can get it. All right. So if we have right here, this is our line, and our line would be our rest position. So this first wave that you see here has an amplitude of 5. There's actually dots on this paper, and so I went up 5 dots, or you can measure it down. So it's either rest to crest or rest to trough. All right, so amplitude is rest to crest, how high it is, or how low it is. Now they should be the same if they're in the same wave. But then this next wave only has an amplitude of 2. I only went up 2 dots or down 2 dots, so that's its amplitude. And then the last wave that I drew over here is an amplitude of 1. So that in a transverse wave, that is what amplitude is. And it's how high or how low the wave is from its rest position. Now when we talk about amplitude with sound, which is coming later, this would be like how high the volume is on your TV, or how high it is on your iPod or something like that. And usually, you can like crank it, or it goes up in number, right? So the amplitude is getting higher or lower depending, and that's controlling the sound level or how loud it is. Okay, so that's how you can kind of think of it. Now, an amplitude in a longitudinal wave is how many compressions are together or how many refractions there are. If there are more compressions together, that means it's a high amplitude. If it's not many compressions, if there are refractions, it's a low amplitude. So I have a picture here. So this would be called a compression, where all the coils are together, and that would mean it's high amplitude. And then over here you have rarefactions, and this becomes a low amplitude. Sorry, I'm doing this backwards, so my finger doesn't know where to go. So you would have a compression, which is high amplitude. Skip, you have another one here. And then you have a rarefaction, which is low amplitude, and then a low amplitude there. Again, please make sure that you're reading the captions in your book of the pictures. That does a lot. Again, I wish I could be there with you, but this is the best that we can do for right now. So we're going to move on to wavelength. And wavelength is very easy, and it's just measuring from the top of a wave to the top of another wave, or from the bottom of a wave to the bottom of another wave, or from compression to compression, or rarefaction to rarefaction. So let me show you my picture here. Okay, so I need to come over here. In a transverse wave, we measure from the crest, which is the top of the wave, to the crest of the next wave, and that's one wavelength. Okay? Or we can do from the trough of a wave to the trough of the next wave, and that's one wavelength. So we have from crest to crest, or trough to trough. And then down here, there we go. Hopefully it's not too blurry. For the longitudinal, you measure from compression to compression, and that's one wavelength. Or you measure from rarefaction to rarefaction, and that is one wavelength. So if you need to know how wavelength works, you're just measuring from the top of one wave to another, the bottom of one wave to another, or from compression to compression, or rarefaction to rarefaction. Okay? The next thing that we have is frequency. That's the number of waves that pass through a given point in a certain amount of time. So if I want to know how many waves are going through an area, well, you have to time it and kind of see what's going on. So I have my definition here. Frequency, the number of waves that pass a certain point at a certain amount of time. And then I made this little graph here. Okay, so I start with 0 seconds, I go to 1 second, and I go to 2 seconds. And I drew my waves, and on this chart I have 8 waves passing in 2 seconds. But to figure out frequency, we want to know how many waves pass in 1 second. So I can count, I have 1, 2, 3, 4 waves passing in 1 second. Okay, and so frequency, it's measured in something called hertz. I think it was named after a guy. Yes, German scientist Heinrich Hertz. Okay, and so when we can abbreviate it, and so it's a capital H with a lowercase z, and this says that the above wave has a frequency of 4 hertz because it's 4 waves for every 1 second. It's not 8 hertz because that's not counting in 1 second. We want to know in 1 second how many waves are happening. So that's how you can figure that out. And then I'm going to turn to page 14 in my book. And the last thing that we have to talk about that all waves have is speed. We can calculate the speed of all these different waves. And you can do it with a formula that is wavelength times frequency. So if you know the wavelength and you know the frequency, you can figure out the speed of the wave. Now I didn't give an example on my notes, but I can just make one up right here. So if the wavelength is 2, there's 2 waves happening, or they're spread out, so there's only 2 of them, and the frequency is 6 hertz. All you would do to figure out the speed is 2 times 6, which is 12, and it would probably be 12 centimeters per second or 12 meters per second, depending on what your, let's see, like what it's measured in. How do I make this straight? Okay, so speed, it says how far a wave travels in a given amount of time. A formula that you can use is speed equals wavelength times frequency. Now say you know the speed and the wavelength, but you don't know the frequency. What you can do is you manipulate this equation here, okay, and you change it so that you want to be able to figure out what frequency is, and it's speed divided by wavelength, and that'll tell you your frequency. So if you didn't know that, that's how you can figure it out. And then same thing for wavelength. Speed always goes on top, so now it's speed divided by frequency, and you can figure out what your wavelength is. And at the bottom it says that the speed unit is probably either centimeters per second or meters per second, depending on, did you measure your wave in centimeters or did you measure it in meters? Now, there may be some practice problems for you that have to do with speed. Just do your best. It's either multiplying or dividing, and refer back to page 14 for that information. But if you have any questions while you're doing your homework, things like that, please feel free to message me, and I will have these notes available. If it helps you to copy them down, go for it. Get out a notebook, get out a piece of paper, and these are just the basics of what you need to know about always wearing fuzzy socks. Amplitude, wavelength, frequency, speed. Alright guys, thanks.